So let's consider the general form for an ellipse, x squared over a squared plus y squared over b squared equals 1. And since there's no plus or minus h or k up here, that means this is centered at the origin. We're looking for the foci here, and the foci are always on the major axis. And the major axis always goes with the larger of A or B. So whatever the max is of A or B, that tells us where the major axis is. So on this one right here, we can see A squared is bigger than B squared. So if A squared equals 81, then A must be 9. And if B squared is 32, then B must be the square root of 32, which isn't as nice as the square root of 81. And we could reduce that, but I don't think that's necessary here, so we're just going to leave it that way. But it'd be nice to know about what the square root of 32 is. That should be what, 5 point something, almost 6. Let's get a calculator. Desmos has been good lately. All right, so about 5.6, and let's graph this just to see it. We're going to need the graph to figure out the foci. So we have our x squared over 81 plus y squared over 32 equals 1. Oops, wrong place. Equals 1. So there's my ellipse right there. And I can see that along the x-axis, I have the longest axis of the ellipse with endpoints at -9 and 9. Those are also called vertices. And then we have the minor axis, the y-axis, with vertices at the square root of 32 and negative square root of 32. And then somewhere on the x-axis are the two focal points of the ellipse. So rough sketch of this. Let's get some axes here. So 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 10. So we have a focal point there. 1, 2, 3, 4, 5. We have another focal point up here-ish. It's always worth your while to graph these. So here's the other focal point. There's -5. And then about here is the other one. So my ellipse looks something like this. To the best of my artistic ability today. And then somewhere in this region is a focal point in here. And the relationship between the vertices and the focal point is kind of like the Pythagorean theorem, that if we say we start with the minor axis value, and then we make a diagonal that's the length of the major one. So then if I come down on a diagonal 9 units, maybe that's going to be somewhere over here-ish. So that's 9. Over here is my square root of 32 on this leg of the triangle. And this leg of the triangle is going to identify the focal point. So focus will be over here. So if I just solve the Pythagorean theorem for this setup right here, I'm going to get the coordinates of my focal point. So we're going to get the legs are square root of 32 squared plus my missing focal value squared is equal to 9 squared. So 32 plus my missing number squared is equal to 81. Subtract that 32 over. So my missing number squared is whatever 81 minus 32 is. So let's see, 81 minus 31 would be 50. So that's got to be 49. squared equals 49. So that means my missing values are plus and minus square root of 49, which is plus or minus 7. So that would be, here's a focal point, here's the other focal point, and the point of the focal points is that any point on the ellipse, like this one right here, if we find the distance from that point to one focal point and that point to the other, these two distances are always, they always add up to the same number. So whether I take these two green lines and add them up, or whether I take, say, these two red lines and add them up, I'm always going to get the same value. And that's the idea of an ellipse. So my focal points, the coordinates, I'm on the x-axis, so they would be, y is 0, so negative 7, 0 would be one of them, and the other would be positive 7, 0 for the other focal point.